In the vast expanse of space lies a small red dwarf star called Proxima Centauri, part of the Alpha Centauri star system, our closest known stellar neighbor. Located just over 4 light-years away, it is relatively near in astronomical terms, yet staggeringly far by human standards. Orbiting this dim star is a planet that has captivated scientists around the world, Proxima b. Proxima b is slightly larger than Earth and orbits within its star's habitable zone, a region where temperatures might allow for liquid water to exist on its surface. This is critical, as liquid water is widely considered essential for life, facilitating the chemical reactions necessary for biological processes. Despite Proxima Centauri's relative proximity to Earth, observing it in detail remains an immense challenge. Even at the speed of light, the universal speed limit, a one-way trip to Proxima b would take over 4 years. To put this in perspective, a single light-year spans approximately 5.88 trillion miles. These distances underscore the enormous technological barriers involved in exploring even our closest planetary neighbors. Nevertheless, scientists and engineers have continued to develop advanced instruments designed to unlock the secrets of worlds like Proxima b. Among the most revolutionary of these tools is the James Webb Space Telescope, JWST, the most powerful space telescope ever built. Equipped with cutting-edge infrared sensors and optics, the JWST is capable of detecting the faintest light from the earliest stars and galaxies. It provides unprecedented detail in its observations, enabling scientists to peer into the atmospheres of exoplanets light-years away. When JWST was directed at Proxima b, the data it collected sparked a wave of scientific interest and speculation. By using spectroscopy, a method that analyzes light by breaking it down into its component wavelengths, scientists can determine the atmospheric composition of distant planets. This allows them to search for specific gases such as oxygen, methane, or carbon dioxide, which may indicate the presence of biological or geological processes. What the JWST observed on Proxima b was unexpected. A faint but consistent glow was detected emanating from the planet's dark side, the hemisphere permanently facing away from its star. This phenomenon is particularly unusual because Proxima b is believed to be tidally locked, meaning one side of the planet experiences perpetual daylight while the other remains in constant darkness. The glow could not be easily explained by natural mechanisms such as auroras, volcanic activity, or reflected light. Its specific intensity and wavelength profile did not match known natural emissions. This led some researchers to propose a more controversial possibility: the glow might be of artificial origin. If this were the case, it would suggest the presence of a technologically advanced civilization capable of illuminating the dark side of its planet, potentially with artificial lighting or energy infrastructure on a planetary scale. Such a civilization would need to overcome the extreme temperature differences caused by tidal locking and engineer solutions that allow sustained habitability and activity in a harsh environment. This hypothesis, while speculative, is grounded in serious scientific inquiry. The search for technosignatures, observable evidence of advanced technology beyond Earth, is a growing field within astrobiology. The glow on Proxima b represents a potential candidate for further investigation. However, the scientific community is approaching these findings with cautious rigor. Extraordinary claims require extraordinary evidence. Before any artificial explanation can be considered viable, every possible natural explanation must be explored and ruled out. Despite these uncertainties, the detection of the glow represents a significant moment in the ongoing search for life beyond Earth. Proxima b, by virtue of its proximity and position in the habitable zone, remains one of the most compelling targets in the search for extraterrestrial life. The planet's characteristics, its mass, orbit, and atmosphere continue to make it a subject of high scientific interest. As the capabilities of telescopes like JWST expand, our ability to analyze distant exoplanets in detail will improve. Future observatories such as the Nancy Grace Roman Space Telescope and concepts like LUVOIR or HAB-X will build upon JWST's legacy, offering higher resolution imaging and more precise spectroscopy. The debate surrounding Proxima b's observed glow highlight the importance of maintaining a balance between skepticism and openness to discovery. While natural explanations currently dominate the conversation, the persistence and distinct nature of the emission leave room for continued investigation. Whether it turns out to be geophysical, atmospheric, or artificial in origin, the discovery will significantly deepen our understanding of this nearby world. If one day we do confirm the presence of intelligent life or advanced technology on Proxima b or any other exoplanet, it would mark a turning point not just in science, but in human history. It would force us to rethink our assumptions about life's rarity and distribution in the universe. Ultimately, Proxima B symbolizes the promise and complexity of our quest to understand the universe. Its study challenges our instruments, our theories, and our imagination. With every new piece of data, we are reminded of how much remains unknown and how much there is still to discover. The search for life is no longer confined to science fiction. It is a rigorous scientific endeavor, grounded in real observations and expanding capabilities. Whether or not Proxima B harbors life, it serves as a powerful reminder that we are only at the beginning of a new era in planetary exploration, one that may, in time, answer the most profound humanity has ever asked. As we stand on the cusp of this new era, the discoveries surrounding Proxima B serve as a catalyst for deeper not only about what lies beyond our solar system, but also about ourselves. The glow on Proxima B challenges us to expand our definitions, to consider new possibilities, and to embrace the unknown with humility and curiosity. The technologies we are developing, telescopes that can analyze starlight for chemical signatures, probes that might one day travel between stars, are not just tools. They are extensions of human imagination, born from a desire to understand our place in the cosmos. Each instrument we launch carries with it the hopes of generations who have looked up at the night sky and wondered what else might be out there. And as we gather more data and refine our models, we must also grapple with the philosophical implications of what we might find. If we confirm that life exists elsewhere, especially intelligent life, our sense of uniqueness will be forever altered. We will no longer be the only known example of consciousness in the universe. We will become part of something much larger. But even if the glow turns out to have a natural explanation, the search is far from over. Every mystery solved reveals new layers of complexity. Every question answered gives rise to more. The universe, it seems, is not just vast in scale, but in depth an infinite well of phenomena, waiting to be understood. Proxima B, glowing faintly in the darkness, is more than a scientific target. It is a symbol of the human spirit, our drive to explore, to question, to learn. It reminds us that discovery is not a destination but a journey, and that the act of searching is itself an expression of who we are. As our telescopes grow more powerful and our understanding more sophisticated, we may one day uncover irrefutable proof of life beyond Earth. Or we may find only silence, a cosmic void where we expected voices. Either outcome will teach us something profound.